what we know so far about React is it's all about building components, where a component is a function. For example, the 101 example of a component was like the following. And a component is a function. At the moment, it doesn't take any arguments, but that's going to change. And at the moment, it doesn't have any kind of behavior either. By that, I mean, you know, there's nothing going on inside here. But critically, it returns what we now call JSX, what we know as JSX. And at the moment, the JSX is completely hard-coded. For example, my list of languages here are all just hard-coded. So that's not really much use. We've changed that as well. And if we want to attach a component to the DOM, then we've got this boilerplate essentially code down here at the end. The problem though with this syntax, and in particular the JSX syntax, is that the browser cannot interpret it. So we've got to convert it into plain old JavaScript, a process we call transpilation. And the last thing we did, that we carried out the transpilation kind of manually, or at least I showed you a way of doing it manually, which was using that online tool, the babelJS.io tool. And the transpile code then just looks like plain old JavaScript with lots of uses of the React.create element. Now, this kind of manual transpilation process, obviously that doesn't scale. So we need some tools to help us with all of that kind of stuff, that kind of background stuff. Can I just confirm now that people can see and hear me as I usually check? Well, you can't see me, but you can hear me and you can see my screen. Can somebody just confirm that? I'm hoping that's a yes.
Yeah, we can see it.
Okay, great. All right. So I'm going to fast forward to where we left off the last day, which was around slide 14, I think. Right. So we need some tooling to make the developer's experience a little bit more enjoyable. So there are two tools that we will use throughout this first half of the module. One is called, long-winded name, Create React App, but a very explicit name. And it's a tool for helping you to create React applications. It does a couple of things. Number one, it will generate a kind of default folder structure for you, something we call scaffolding. And it'll put some generic code in there as well. So you actually have something that you can run straight away. The second thing it does is it provides its own web server. And what the web server does, and I mentioned kind of this to you the last day, what the web server essentially does is it monitors any changes that you're making to your JavaScript code. A React app now is obviously going to be made up of multiple JavaScript files. Each file will have one component code in it. That's the way we modularize it. And component files may be referring to other component files. But as a developer, you're making changes to files, to JavaScript files, and every time you save a file, update a file, the web server will actually pick that fact, and it will automatically transpile that code. And what it will also do is it will gather up all of your JavaScript files, transpile all of them, bundle them all into one JavaScript file, and send that single JavaScript file down to the browser with an accompanying kind of default HTML page. And it does that every time you make a change to a file. You'll go through a full retranspilation. Well, it's clever enough to know that it only needs to retranspile the ones that have changed, but it will rebuild that single JavaScript file that it sends down to the browser. So what's sent down to the browser is all of your components that have been transpiled into plain old JavaScript. And it does some other kind of intelligent things as well, like it minifies the size of that file by getting rid of any white space and stuff like that. And it also performs what I'm calling live reloading, which means anytime you make a change to your component code, it will reflect that change in your, or that change will be reflected in the browser. So you get that immediate kind of feedback, if you like. The second thing it comes with is something called a bundler or a builder. Now, this, what I was describing up here with this server, that's great for development, but it's not really obviously a great experience if when you want to deploy your application in production mode. And what a builder or bundler will do is it will again go through all of your JavaScript file, transpile them, and minify them and convert them into a single unit, if you like. It'll create essentially a production version of the app. We won't be doing a whole lot of that, although you do it in the second of this week's lab, but we won't be doing it from then on in. So that's Create React App. The second tool is a tool for developing individual components. And it's a tool called Storybook. And it has lots of the same features as Create React App. But what it is, as I said, is a tool that you use for developing individual components. It kind of provides a nice environment for that. It comes with its own server as well that does retranspilation and all that kind of stuff. And you know, if you're part of a large team developing a React app where each person on that team has maybe been assigned responsibility for developing a component, what you'd like to be able to do as that developer is ensure that your component is displaying properly on the web page. But you don't want to do that in the context of a large app. You just want to do it in isolation. And Storybook allows us to do that. And it also helps us to develop better components because we're only concerned with developing a single component and examining it in kind of isolation. So it's Storybook that I want to talk about a little bit today. And you will be using it in the, if I go to the website, and if we go into this section, in this lab, you'll be using Storybook only, I think, yeah, you're only using Storybook. Whereas in this lab, you'll be using the Create React App tool. So Storybook, you install it as a separate npm install, just by the way. And as I kind of alluded to there, it has two parts to it. It has a web server that does retranspilation and all of that stuff. But it also comes with its own browser interface, which I'm just calling the Storybook UI. And this is what the Storybook UI looks like when you start up, essentially when you start up the Storybook server. It goes through all of your components, finds all of your components somehow, and it displays them. It then kicks off a browser tab, and it displays all of the components on the left-hand side. And these are going to be clickable. And when you click on them, it'll show you how that component renders on the right-hand side. So that's ideal, really, for what you want. So again, like I said, in a large software house, they would have a catalog of components that you can browse your way through, as well as using it in development mode. So that's what the Storybook UI looks like. Because remember now, if we're developing a component in isolation, we don't have a React app to stitch that component into. So we need some way of being able to see how does that component render in the browser. And Storybook provides its own kind of web UI that allows us to do that. Where does this name kind of Storybook come from? If I just go back for a second to this little 101 example of our component that we had. And you might remember from the last day, what the component does is it displays a list of languages and also a header, right? But I've had to hard code the number of languages, and I've had to hard code the language names, right? But it's a component that displays a list of dynamic programming languages, which is why I call the component dynamic languages. Okay, now, in general, a component we say could have many states. A state now in the context of our dynamic languages component would be the list of languages, okay? And the list of languages, the number of languages in that list might somehow dictate how they should be displayed on the screen. We might actually decide that as part of the dynamic languages component. So, for example, we might decide that for this dynamic languages component, if there are 5 or less languages to be displayed, then it just renders them as a list of languages. If there are more than 5 languages to be displayed, it should just perform a form of pagination. You know, display the first 5 and then have, let's say, a more button. And when the user clicks on the more button, it displays the next 5, and so on and so forth. We've no idea how to implement that more button now, but that's okay. We're only at kind of design stage at this stage. Or the third kind of case would be, let's supposing it was an empty array of languages. What do we want the component to display then? And maybe we decided we just wanted to display a message saying no languages rather than just doing nothing. So I've got 3 Maria made up cases associated with this dynamic languages component. Now, in the world of Storybook, we will refer to these as 3 stories associated with this component, because there are 3 different states that my component can be in. And each state has a slightly different way of being rendered on the screen. Okay, so that's where the name Storybook comes from. It's actually linked to user stories in the world of user requirements analysis, which I won't get into. That's really where the term story comes from, but it's being applied in this React component world, if you like. Okay, so components may have several states, and that would be part of the design process of the component. I'm just giving you the states here, right? But you might have to dream up that yourself. Each state is termed a component, and the state affects how the component is rendered on the screen, all part of the design process. So we can actually, so really what Storybook will do in real life is not only does it display the components here on the left, but it displays the different states that you have defined for that component. Okay, the names here correspond to, they're just kind of made up names, but they are the stories associated with a component. And now it turns out that by clicking on one of the stories, i.e. states, then you see on the right how that component will render for that particular state or story. In a large software house, and for a large React app, you may have quite a large number of components. So rather than listing them linearly kind of down here on the left, what Storybook allows you to do is to group them into meaningful groups, just to give us a slightly better UI experience during our component development. And as well, you know, we would use Storybook as well as a way of browsing our component catalog. Just go off on a tangent for 1 second, and I'll come back to Storybook. Just a little bit about JavaScript. You may know this already, but obviously for any kind of JavaScript project, you're going to break up your JavaScript code into multiple files, or what we call modules. And some of those files or modules may want to refer to other modules so that we can get reusability of modules. That's just standard programming practice, if you like. Now, before ES6 JavaScript came along, we could modularize our JavaScript code, but we had to use a third-party library to facilitate modularization. Whereas from ES6 onwards, i.e. 2015 onwards, modularization has been built into the JavaScript language. And I'm saying there are 2 options available to you in terms of how you how you link one module to another module, or how you import one module to another from another module. There's the default export option and the named export option. And just give you an example of both of those. So let's supposing I've got a JavaScript file here and it defines, I'm not talking about React now anymore, I'm just talking about plain JavaScript. I suppose we've got a function, and I know this function will be used by other modules in my application. So what I can do is I can export the function, but I'm actually making it what I'm calling the default export. Note the function doesn't actually have any name, right? But so this is making the function available to other modules. Let's supposing this is another module that wants to use the function above, and so it has an import statement. It can call, because it's the default export, it can call the thing that it's importing anything it wants to. And then there's the keyword from, and then you have the path name of the JavaScript file that contains the thing that you're importing. So it looks like here I'm importing the function. I've decided to call it myfunc, and I'm just invoking myfunc then. That's the default export idea in JavaScript. The other thing is what are called named exports. And here's an illustration on the right. With named exports, the things that you're exporting have an explicit name, whereas the function on the left didn't. And you can export anything. So it looks like I'm exporting a const, and I'm exporting a variable and a function, and maybe a class as well. There's no class here though. So I'm exporting lots of stuff in this lib.js file. In the import statement then, on the other side of this modularization, in the import statement, you've got to know the names of the things that you want to import, and you don't have to import all of them. Here I'm only importing 2 of the things that are being exported, and you've got to wrap the imports names in curly braces. Okay, so that's an example of what we call named exports. You can mix them as well. So this file here could have a default export as well as the named exports. Back to Storybook. So I've got this component, and as part of my design process, I know that there are different states associated with this component. Now, from a Storybook perspective, what I've got to do is to write stories for one story for each state. And it's these stories, that's what the Storybook server and the Storybook UI, that's what helps it to work out what it should display on the left-hand side. By the left-hand side, I mean what it should display over here, right? It gets that from the stories that you've written. So how do we write a story? We put the code into a JavaScript file. The extension of the file isn't prescribed, but a common file extension is .stories.js, and I'm using that in the labs as well. And so here's an example, albeit kind of abstracted a little bit, of a story implementation, of a stories implementation for my dynamic languages component. So here we go. I'm importing React. By the way, when you're importing something from a third-party library, as opposed to one of your own files, you just give the name of the library rather than a path name to a particular file. So here I'm importing React, and here's where I'm importing my dynamic languages component. Now, how you code this stories file is predetermined. The first thing you've got to do is you've got to have a default export, and you've got to assign to that an object. And the structure of this object is also predetermined. Essentially, it contains metadata about what this file contains. You have to have a title property, and it can be any string that you want to, but it would be obviously meaningful to give it a name that somehow reflects the component that it relates to. And a component property that refers to an instance of the thing that of the component itself, right? So that relates to that there. That's your default export from this stories file. And it's, as I said on the right here, it just contains metadata. You then have to implement each story, and each story is implemented as a function, and I'm using the arrow function syntax. And don't confuse default here with default up here. I should have used a different name here. Maybe I should have used basic, okay? But you've got one of these now for each story that you've identified for your component. And for our dynamic languages component, I decided there were 3 stories, as I explained earlier on. So these are the implementations of the 3 stories. This story here looks like the one where I give it an array of 5 or less languages. So within my function, I'm just creating an array, putting some entries into it. Now, what the function must return is an instance of the component itself, and that is what's happening here. I'm returning an instance of my dynamic languages component. Now, we haven't seen this so far, but you nearly work it out, and I'll talk about it in more detail in a little while, but this is essentially how we pass data into a component. So I'm passing my array of languages down into the component so that it can render them. Okay, but just purely from a stories point of view, you create your stories file. You've got to have as the default export the metadata for that, for the related component. And then you've got to have a function, one function for each story implementation. And that function must return an instance of the component that the stories relate to. I said earlier on that you can group your components in some sort of meaningful way. And the way you actually tell the Storybook server that your components are categorized is in the title part of the metadata. The slash here is actually significant. The Storybook server knows that when there's a slash there, then what appears to the left is a category for this kind of component. So I've got a group A slash, and I've got another stories file that has group A slash. So it looks like these two stories relate to components that are in the same group. It's up to me to decide what the groups are. Whereas down here, I've got a component that's in a different group. So this slash is how the Storybook server, if I go back, it's how it works out, you know, how to render this stuff here and put them into groups. That's Storybook, but the reason I'm talking about Storybook is because I'm using that as the vehicle for explaining some more basic aspects of components. And I'm going to explain this by using sample code. Now, the sample code comes with this lab here. It's an archive that you download and unzip it and import it into VS Code. And when you do that, what you will get is this project here. And if we just drill down into the source folder, so it looks like I've got components, and I've decided to break my components up into 2 groups, one called exercises, and it's you're going to be filling out these, and the other is called samples, which I have implemented. I've also got a stories folder, and surprise, surprise, in there, I've also used the same subfolder structure. And so if I go down into the sample subfolder, I've got all of my stories. So there's one of these files for each of my components. And what you do is, as well, just by the way, right, well, if I just glance at the package.json, I'm bringing in some Storybook third-party libraries, as well as React and React DOM, of course. Actually, I don't think I need React DOM, but I definitely need React. And as well, there is a .storybook folder up here, which just contains configuration information for the Storybook server. You never need to go near it or modify it, but there's one thing in there that's kind of enlightening, I suppose, mildly. And this is how you tell the Storybook server where to find the stories implementations in your code base. And that's really what I'm doing here. Now you shouldn't go modifying that, but that's how the Storybook server knows where to find the stories implementation. To start my Storybook server, I need to, is it already running? It might be already running actually. Yeah, okay, to start it, I just do that, npm run storybook. Now, when I hit return here, what the Storybook server is going to do is it's going to look at this main file in here that tells it where all the stories are, then goes down to where all the stories are, and it essentially reads all of these, gobbles up all of these, and if I open up any one of them, from the stories files, it works out where the actual components are implemented. So it essentially kind of sucks in all of that JavaScript code, be it stories or components, transpiles everything, opens up a tab in the browser, and then displays what does it display? It displays the following. Let's just start the server. It's kind of jumping around in me. So you can see it there, it's kind of going through all the source code, and voila, it displays all of my components and their kind of stories on the left-hand side. And if I click on any one of these, I see how the component is actually rendering for me. So the whole point of this, though, is to talk a little bit more about React components. Now, the only component we've seen so far, everything is hard-coded. What if I want to be able to embed variables within the JSX, and thus making the JSX a little bit more flexible? So the way you do it is you've got to wrap the variable reference in curly braces within the JSX. So the example hopefully is clarifying this. So I'm sticking with my kind of dynamic languages idea. And I've declared two variables here, and one of them contains an array of language names. And then down here, if you look at the JSX, I'm actually I'm dereferencing the array, referencing entries within my array. But because that's essentially variable referencing going on here, I have to wrap those in curly braces. And by doing that, the way the React kind of runtime works is, first of all, evaluates this expression, which means it's going to pick out one of the entries in my array. And then the result of that evaluation is what goes into my JSX. So it's as straightforward as that, really. Now, turns out, right, that you can have anything you want to inside your curly braces. Here, I've just got a kind of variable reference, if you like, albeit indexing into an array. But you could actually have a function invocation, and then it's the result of whatever the function returns. That's what gets inserted into your JSX. So it's much more powerful than just embedding static variables. A slight indication of the power of this embedding is kind of being illustrated here, right? Here I'm constructing a string template. You might remember string templates from JavaScript, but that's what's going on here. So at runtime, it's going to construct this string dynamically, and then the result of that construction is what becomes your H1 header. But it's a string template that's being used here. So we told to look at sample 02 to Now the component, I guess, we've already seen, but just to be, okay, there's my component. But I need to write a story in order for Storybook to be able to render the component. And so just using the numbering system, it looks like it's 0, 2. I've called all of these kind of something similar rather than, well, maybe through laziness more than anything else, but usually the names of the files would correspond to the name of the associated component. And that would be the more common. So here's my stories file for that component. Not that interesting because there's only one story. It doesn't have multiple states as such, but it's following the structure that I talked about there a while ago. So here's my metadata for the component, and here's the only story associated with it. And so because I've written that story, that is what allows the Storybook server to essentially generate this one over here. Okay, so basic, the story name was basic, and this is kind of some sort of reference where it got this from, which is not a direct component name, but you can see it got it from here. Now, as I said, normally what you'd have here is just a component, some variation on the component name, but because I'm describing some basics of components, I would give them more meaningful names to explain what I'm trying to demonstrate. And what I'm trying to demonstrate in this case is Jsx Embedded Variables. Okay, so from a React point of view, though, the important point is how do we embed variables, or more generally, how do we embed JavaScript expressions within our JSX? And the answer is just wrap the expression in curly braces. And so here's an illustration of it. Still though, this component is still completely unreusable. The languages, other than going into the source code and changing the languages here, that's not really making this component reusable. It's still completely isolated, if you like, from the rest of the world. In order to make a component reusable, we'd like to be able to pass data into it. The data, in the case of our dynamic languages, would be pass in the array of languages, and as well pass in the header that we want to have associated with that array of languages. Now, in the JavaScript world, in other words, we want to parameterize a component. In the React world, we use the term props. So props are parameters or attributes that you pass into a component. And so there are two questions. One, how do I pass parameters or properties or attributes into a component? And number two, how does the component access those parameters? We've already seen an example of how you pass parameters in. So this is how you do it here. So it's up to you to decide what name you want to give the parameter. And here you assign it the value. And because that value could be a variable reference or an expression, we need to wrap it in our curly braces. Another parameter, value, etc., etc. So this is very much like the HTML syntax, where we would call these attributes of the HTML element. But in the React world, we call these props associated with the component. That's how you pass data into a component. How does the component actually reference them? Well, what the React runtime does is it essentially grabs all of these, creates an object where the keys of the object correspond to the prop names and the values of those properties, or whatever value you assign to them. So it creates that object for you, and it passes that object into your component function. You can actually call this thing anything you want to, but the convention is to call it props. So props is an object with key value pairs, and then you just dereference that object in the normal JavaScript way. So props dot prop name, where this has to correspond to one of these, obviously. and then you do whatever you want to with the property. You may do some computation of it, or you may stick it straight into the JSX, embedded into JSX. Usually you do some sort of computation. The important thing to remember about this props object is it's immutable. You cannot change the values associated with the keys in this props object. Even if you try to, it won't throw you a compilation, kind of runtime error, but it won't reflect the change at all. So they're completely unmodifiable or immutable. And deciding what props a component should have is part of the design process, and we're not going to get into that today. So sample 3 demonstrates this. So if we look at the component first, just as I said, you know, here's my props object, and I've just decided to go straight to the JSX and do my dereferencing in the JSX. Now I have to know, obviously, I would have to know what are the keys within this props object. So where do I get that from? Well, in our case, if we look at the story associated with this component, the story will tell us what the prop names are. So here we go, this line here. I've decided to call the array of languages, and I've decided to call the header, header. And again, as I said, deciding on these prop names is just a design decision. So that's what, that's that. And sample 3. No great variation from a UI perspective, but that's what sample 3 looks like. And just to prove to you that, you know, it is making my component reusable. If I go back to my story, and let's supposing I change this to what do I change it to? Maybe F#, which is not a dynamic language, but it doesn't matter. Make it sharp. Save it. Now, when I save it, my Storybook server is going to go through a retranspilation, which you kind of briefly saw there at the bottom. And there's kind of F# reflected in the UI. So the general point anyway is props is this mechanism to allow us to pass data into a component, thus making that component much more reusable. Now, my component is still, if I just flick back to the component there, it's still very much, where's the component? The component, you know, it's still hardwired to only expect 3 languages. If my languages had 10 entries in it, my component is still only going to display 3 of them because it's hard-coded, as I said, to only do that. So that's not great. How do we improve on that? And we'll go off on a tangent for a second in order to demonstrate the next example. What I'm posing here is I can actually, it's valid in a component function. It's valid to assign some JSX to a variable. That's a valid assignment statement. And I'm posing the question, well, how come that is going to be possible? And the answer to that is because at the end of the day, this is going to be transpiled to that. And now that becomes a valid assignment statement in plain vanilla JavaScript. And you know, that's what we were discussing last or in the previous lecture, this React.createElement stuff. So assignments like that are going to work for us. And there's more flexibility in terms of how we can move JSX around the place and assign it around the place. So where that leads us on to is a common feature of components is where it wants to generate dynamically an array of either an array of components or an array of JSX elements, where the number of entries in that array of JSX elements is controlled by another array that just contains the data that you want to embed in those JSX elements. So you've got a data array, and essentially what you want to do is map over that data array, and you want the map to produce an output array where the output array has JSX elements within it. Okay, so we're combining what we saw from the previous slide with the array map function, which we've seen a couple of lectures back. And that gives us a very powerful little pattern that we will use quite a lot actually throughout this first half of this module. In my case, what I want to generate is I want to generate a list of LI elements. Now, I've just for the sake of variability, I've moved away from languages, and let's suppose my LI elements contain an embedded hyperlink within them, where the hyperlink brings you to the home page of a single page app framework. Okay, but I want to generate a whole sequence of them, if you like. So my data in this case would be a React framework name and its associated homepage URL. So if we look at sample 4 and we look at the story this time to begin with. So here's my data array. It's an array of objects with some key value pairs, and each object has a name property and a URL property. And I've already said, you know, what the data represents. And here's my component, which we haven't looked at yet, though. Here's my component, and I'm passing it in my data array above there, and I'm passing it in a header as well, which is less interesting, really. So it's how my component is going to use this array is what's going to be interesting, because we've seen now that what we want the component to do is generate an LI element for each entry in this array. So let's look at the component. And so here it's picking up the array and it's mapping over it. And we know from before that the map method expects a callback. And here's my callback. And the callback is an arrow function, and what it's returning, and I've used the shorthand version of the arrow function, which it probably wasn't a clever idea. Maybe it's trying to be too clever, but the long-handed version would be where I take all of this and bring that up a bit. And I need to return this. And because it's a multi-line, now you wouldn't have known this, but because it's multi-line, we need to put a multi-line in parentheses. Is that syntactically clean now? Return that. That closes that. And that closes that, I think. So let's format it. Okay. So the upshot anyway is that this here is going to be an array where each entry in the array is some JSX, in this case, that looks like that. And if I want to render that array on the screen, it's actually simple enough. I can just do it like this. I can just refer to the array like that. And because the array contains li elements, it makes sense that I should wrap that in a ul element. Just basic HTML knowledge tells me that. So this pattern of mapping over a data array to produce an array of JSX elements, in this case, could be even components, but it's JSX elements. That's a pattern that we would see a lot in our code. And if I save all of that, hopefully I haven't broken it. I didn't change anything there, I don't think. So it's sample 4. Okay, seems to work. And again, from a dynamic, what's nice now about this is we're not hard coded to, 3 entries in my list anymore. And just to prove that, if I go back to my story, did I change that at all? Did I save it? I don't think I did actually. Sorry, let me just save that. Okay, still works. Surprise, surprise. If I go back to my story and, let's supposing is that my story? That's not my story. Where's my story gone to? If I just expand this to like so. I'm missing a comma at the end of any of those. No, okay, save that. And, so the component now is much more flexible, if you like. So we're slowly getting places with our components and making them both reusable and adaptable, if you like. Okay, so a component returns JSX, but it can only return a single JSX element, right? So or a component can actually return another component, but it's this idea that it can only return a single element. And as I mentioned, as I kind of illustrated there a moment ago, if a component is returning a multi-line piece of JSX, which 99% of the time it will, then you've got to put parentheses around the JSX just to help the JavaScript runtime to work out what's going on. So that's fine. The other point is that it can only return, this is what I was saying a moment ago, but a little bit previous, it can only return one element. So for example, this is not going to work. Here I'm trying to return 1, 2, 3 elements within my return statement. And, from any knowledge of programming, we know that in programming, be it a function or a method, it can only return one thing. So here it looks like we're trying to return 3 things because we know how these are going to transpile, what these are going to transpile to at the end of the day. So how do I solve this problem? The solution is simple enough, really. This is the error that you get if you happen to make this mistake of trying to do something like this. And the error message, it will appear in the browser, and it's fairly informative, really. It tells you that you're trying to return more than one thing. How do we solve that? The solution is pretty simple, really. We just make sure that we wrap it in a div, and now suddenly we're returning one thing. We're only returning a div, but of course it can have nested stuff inside it. So that's fine. That's the lesson, really. But that would mean that in a large application with lots and lots of components, we're going to have all of these additional divs. And the only purpose of the divs is to satisfy this rule that we have to follow. But each of these divs are actually going to be represented as a separate node in our browser's DOM data structure. So that means the DOM is a much deeper data structure because of that fact, even though the divs don't really serve any purpose other than satisfying this reactor requirement. And that can be those additional div nodes in the DOM can be significant for very large React apps. And obviously the bigger the DOM data structure, the slower it is for the browser to carry out its kind of repainting and reflowing processing that it does, which I talked about a couple of lectures back. And that was a significant issue in the early days of React. And so the React design team came up with a better solution. And the better solution is they essentially introduced a new tag, which is called the Fragments Tag. And it serves the exact same purpose as the div tag on the left. But the thing is that this fragment tag has no representation in the DOM data structure. And so you'll see me using this fragment tag a lot. The only reason you might use a div instead of the fragment is if you want to assign some CSS styling to the entire div, and you'll see that happening as well. Now, the next point is, and I think I mentioned this before, but now that we know a little bit more about components, it becomes a little bit more tangible. I'm saying all React applications are designed as a hierarchy of components, where there will be one component at the top of the hierarchy. It can have any number of children, and those children in turn can have any number of child components, and so on down. But it's always going to be a hierarchy with one component at the very top. You'll never get away from that. And so to illustrate this, I have another sample 5. And from a UI perspective, this is how sample 5 renders, but it's actually made up of 3 components. And I've just used boxing to try and help us where the boundaries are between these components. So the outer box here represents my component at the top of the hierarchy. And it looks like it has 2 child components that it uses. And it also seems to generate some of its own JSX. So it has a mixture of JSX and use of other components within the outer components JSX. And so how it looks from a coding point of view, there's no real surprises, but it's the fact that we're just getting bigger and bigger, I suppose. Here's the outer component in that box structure that I showed you. And here we're actually importing 2 other components, which are the inner boxes in the diagram in the picture that I showed you. And again, this component is, here's where it's using one of the components it's imported. Here is where it's using the other component that it imported, and it has some of its own local HTML, if you like, as well, mixed in with it. And, you know, in a real life situation, this inner component here, if we looked at its JSX, it might be using other components, which would be its children, and so on and so forth. So things are getting a little bit slightly more complicated as a result of all of this. The story, given that now the inner components, one of them is the component that generates a list of single page app frameworks, which we've already seen. The other component is the one that generates a list of languages. And I've got to pass in the data for these two inner components, I've got to pass in the data in my props object. So this props object is going to be a fairly significant object. And if we look at the corresponding story, so again, here's all my data. Is it all here? Here's my array. Oh yeah, here's my array of languages. Here's my array of single page app framework stuff. And you know, I've decided to create one overall object that contains the other two data objects, and then pass that in as a single object or a single prop. I could have, if I wanted to, I could have passed in these two arrays here individually as separate props. There's nothing wrong with that. So that you don't have to, you know, combine them as I did here. You could pass them in separately. In fact, the more I think about it, it probably would have been slightly better maybe if I passed them in as individual parameters into my component. And right, that's that. And I think it's also, check my time. Component hierarchy. I'll leave it at, I'll just finish on this slide. We're using React version 18, which only came out in March of this year. And as far as we're concerned, there was one slight difference between React 18 and all of the versions of React that predated that. And it is in how you attach a component to the browser's DOM structure. We know that the way you do it is in React 18 is like this, but in React 17 and everything before that, you actually did it in a single statement like this. So if you see, if you're reading around about React and there's sample code with it, and this is how they attach something to the DOM, then you know that article was written before March of 2022, and it is using React 17 rather than 18. The article is still going to be very useful to you, but just be aware of the fact that this will actually still work in React 18. But if you open up the developer tools, you'll see that the React framework gives you a deprecation warning message indicating that this approach is going to be deprecated probably after React 18. Material UI is a third-party library for developing React apps, and we've used it in the second lab linked to the first lecture. And I just want to give you some background to it. We'll be using it throughout this module, so it's pretty important. Back in 2010, Google took it upon themselves to come up with a set of principles or guidelines or standards related to the design of user interfaces for both native apps and web apps. And what they drew from was not so much what was best practice in that world at the time. They actually turned their attention towards classic design principles. In other words, how real world textures and surfaces are represented on pen and paper, how we represent light and light reflection and shadows, etc. And from that, they came up with a kind of a vocabulary that we could apply to user interface design. But also not just those classic principles themselves, but how can those principles be enriched and enhanced through technology and indeed science. And the collective label for this set of principles is what they call material design. Material just being a metaphor in the sense that it came from real world classic design principles. So that's quite high level, but they took the set of principles, if you like, and from that they derived what they called a set of components or material components, which are really kind of building blocks. They use the word component, which is not necessarily linked to anything related to React, but It's more building blocks is how you should think of this slide. And they have 5 categories of building blocks. So this is where it becomes, as I say, linked back to user interface design. So one category of building blocks is what they labeled display building blocks. In other words, how do we structure the content of a web page? And so we use concepts like cards and grids and lists, which you're familiar with, and we'll be using those in this module via the Material UI third-party library. Navigation is obviously an important part of a web app or native app. So there are some core components or building blocks defined by the material design document, which we can leverage. The 4th category there, obviously inputs are a very important part of any web-based app, and there are core components linked to that, and communication building blocks or components as well. So the material design system is a set of principles and a set of building blocks that allow us to realize those principles, but there is still a lot of flexibility available to the individual, and that comes in the form of theming. Google did not simply want us to copy the way they do things. Now, by theming, we mean what kind of color scheme you wish to use, what kind of typography you'd like to use, and that's all kind of a branding that you might want to associate with your website, which is unique to your website. So there is still that flexibility available to you within the overarching kind of material design principles and building blocks. Although they do recommend that in relation to color, that you should have what they categorize as a primary color scheme and secondary color scheme. Again, just to achieve consistency from page to page from a coloring point of view. And you can define what is primary and secondary for your particular application. In relation to typography, they actually defined 13 different typography styles, which really kind of fit all possible scenarios. And you should pick a subset of those and use them across your, or at least the material design system is recommending this. Pick a small subset and use that of typography styles and use them consistently across all of your pages. And we'll see that again in this module. So where Material UI comes into the picture then is Material UI is a React-based third-party library that is linked back to the material design system set of principles. And so if you did begin or if you did complete the lab from last week, and you will see in subsequent lectures that we will be using components from this library which are linked to those building blocks that I mentioned there. So we'll have a card component, box, grid, etc., etc. So rather than us trying to design these ourselves, we can just pick them from the library and tweak them. By tweaking, I mean you may want to slightly modify the default styling associated with them. As well, the Material UI allows you to define your own theme, although I don't get into that in the labs, but you may wish to read up on it yourselves. Now, the components, the third-party components that you will use from the library all come with their own default styling. But as I mentioned there, you may wish to tweak that styling a little bit. So that means obviously CSS in the case of web apps. So the Material UI team decided that they were going to use what's called the CSS in JS model as a way of allowing us developers to customize the styling of a Material UI component. Now, just to explain how this works, first of all, if we, on the left there, if we didn't have this CSS in JS approach, which is something we can use independently of Material UI, by the way, but if it didn't exist then and we wanted to style some JSX, then how we would approach it is what you see on the left. We would write our custom CSS in a CSS file as normal. And then we apply that CSS to our JSX element using the class name. We import the CSS file into our JavaScript file, and then we use the CSS rule, if you like, which I've defined up here. We use it using the class name attribute, which we've seen already. So that's, if you might call, just plain CSS application. With the CSS in JS model, this is how you can approach it. You can actually write your CSS as a JavaScript object, which is what I've got here. So this here is the equivalent of my CSS over here, but this is coded as an ordinary JavaScript object inside my component file, if you like, which is a JavaScript file. And to apply that CSS to a JSX element, I use the style attribute, and I just simply refer to the object that I've defined up here. I refer to it, obviously I've got to, because I'm embedding a variable in my JSX, I wrap the variable name in curly braces as before. And that has the exact same effect as what we see on the left. Now, you can't write just any old attributes that you want to inside this object. The attributes have to correspond to the equivalent attributes in the CSS world. But, and the but is important, you've got to use camel case for those attributes. So for example, background color spelled like this is the equivalent in CSS as background hyphen color. You cannot use background hyphen color over here, because the hyphen is going to be interpreted as a minus, and so the JavaScript runtime is confused. It thinks you're trying to carry out some sort of subtraction operation. So you just need to remember that whatever a CSS attribute is called in the CSS world, you've got to convert it to camel case in order to use it in this CSS in JS approach. And other than that, then it's pretty straightforward, really. If you did use camel case here, the Babel transpiler is actually clever enough to pick it up and realize that that isn't going to work. So you will get a warning message about it. And it's as straightforward as that, really. And you'll see this being used now quite a lot in our code when we're trying to customize the styling for Material UI components. So this is what we know so far about React. It's all around this JSX syntax, which allows us to code the UI description part of a component. We haven't talked about UI behavior yet. Our components are static rather than dynamic, but that's going to change in the next lecture. And in this JSX syntax, we can embed variables using the curly braces. We then talked about components, and a component from a syntax point of view is a function that takes an argument. The argument we tend to refer to as a prop, where the prop is this mechanism that allows you to pass data into a component, thus making the component more reusable. And we tend to then embed that data in our JSX within the component. A component function must return JSX. That's the only thing it can return. Otherwise, it's not a component. It's just an ordinary JavaScript function. Components can be nested inside of each other, and that's really where the power comes. As I said a few slides back, every React app is nothing other than a hierarchy of components. That's, in other words, components nested inside other components. We then talked about Storybook, which is this tool that allows us to develop components in isolation, and it comes with some nice features. It does auto transpilation for us, and it renders our components for us, because the Storybook UI comes with, the Storybook tool comes with its own browser-based interface. So it's a nice environment for developing components in isolation. And finally, then we talked about material design in general and the Material UI React library, which is an implementation of the material design system. Okay, that's it. Thanks.